All right, welcome students. And again, we're going to be talking about stoichiometry, and this is in essence part two of that. And each one builds upon the other one. So whatever you learned before in part one, we're actually just going to add to that. So nothing changes from part one. We're just going to add one more step. And the same thing will be true of part three. We'll add one more step on top of that. And each one, it's very logical as you take one step and add it on to the other. It kind of makes sense why you would take that step. And if you remember, we were talking about stoichiometry. It's called the measurement of elements, and basically it's like you have your recipe or your balanced chemical equation, and that's your reaction. And what you're doing with it is that's your ratio that you would normally have, just like in a recipe. You would have, maybe 2 cups of flour and half a cup of sugar and 2 tablespoons of butter, and that's your ratio of ingredients to one another. And then ultimately what they will produce, they'll produce 16 cookies or whatever it might be. In the same way, a chemical reaction, that's your ratio of one thing to another. And what we said was that sometimes you want to produce more or less than what you're given in your chemical equation. So we're going to see more of that today. And we're going to start the other day we dealt with moles. And you have to kind of start there because the chemical equation is given in moles. We said all your coefficients there, those are moles. And the only way to move from one substance to another is to go using coefficients or using moles, to jump from moles of one to moles of the other, because that's the only thing they have in common is that ratio that is given in the balanced chemical equation. That ratio for a particular reaction will never change. What we're going to deal with today is kind of go a step further, and we're going to go from moles and ultimately go into grams, or learn how to do that. Or if I was starting in grams, how would I get to moles, or vice versa. If I was starting in moles, how would I get to grams? Because the reality is, more often than not, when we actually measure, we're going to measure in grams. That's going to be a little bit more practical, so we have to know how to convert there. And so we're really only adding one more step, and it's a step that really technically you already know how to do because we already had a section on conversions between moles and grams. And so you should already know how to do this. So let's go ahead and move on and take a look at our first problem. Our first problem here is you have the equation, and let me see here. Oops, let me go back. And I'm trying to get my thing to appear. And let's see here. Let's get my laser pointer. Okay, here's my laser pointer. That's what I was looking for. All right, if you look, here's our chemical equation. We have P4 plus 5O2 yields 2 diphosphorus pentoxide, and there's our question. It's the same question that's in your notes, and you will want your periodic table and calculators handy so you can follow along and see what I'm doing. And basically the way we're going to do this is we're going to go from moles of oxygen, because that's what we're given to begin with here. And so we're going to go from moles of oxygen, and we're going to go to moles of diphosphorus pentoxide. And then we're going to go from moles of diphosphorus pentoxide to grams of diphosphorus pentoxide. And we have to do that first step, moles of oxygen to moles of diphosphorus pentoxide. I can't go moles of oxygen to grams of diphosphorus pentoxide. There's no relationship. I have to get from moles of one thing into moles of another. That's the only way I can jump from one substance to another, because that's the only thing they have in common. So we're going to see how we do this here in just a second. All right, let's go ahead and move on to our next slide. And our next slide, if you'll see here, we have the problem set up, and we have our chemical equation at the top, and we have our 0.78 moles of O2. And I want to get out of moles because ultimately the question was asking us, if you look at your question in your notes, the question is, I want to know grams of diphosphorus pentoxide. So the first thing I have to do is get into my substance, diphosphorus pentoxide. And this is why it is so necessary to keep track of your substances, and why units and what units you're in are extremely important. So not just knowing that I'm in moles, but moles of what. in this case moles of oxygen or moles of O2, and I want to get into moles of diphosphorus pentoxide. So you notice as I set up my first conversion here, I take care of my units first. So as I come here, I put moles of O2 on the bottom, so those cancel out with my moles of O2. And I want to get into a new substance, which is diphosphorus pentoxide, so I put those up top here. And then, if you remember, when you're going, it's a mole to mole conversion. What I want to do is the numbers or values that I'm going to put there come from my coefficients in my chemical equation. So here's my coefficient for diphosphorus pentoxide. So that goes 2. And then here's my coefficient for oxygen. And so I go ahead and do that. And then I'm going to do my math, and this is where it's going to handy to have a calculator handy. And so 0.78 times 2 divided by 5, and that gives us an answer of 0.312, and that's moles of diphosphorus pentoxide. And you'll notice I just transferred that down over here. So we've got that written over here. We're not done yet, because you'll notice that it's 0.312 moles of diphosphorus pentoxide. But I don't want to be in moles of diphosphorus pentoxide. I want to be in diphosphorus pentoxide, but not moles. I want to be in grams. And this is where you have to be cautious and pay attention to what your units are in. Inevitably, I have students that every year they make this first conversion just fine. They have no problem. They set it up correctly, but they don't pay attention to the units, and so they assume, oh, I made a conversion, I must be in the right units, and they assume they're in grams when they're not. So I have a second step, and that is once I'm in the right substance, now I need to convert to grams. And you should already know how to do this. This is what we did last section. And so now, again, I'm going to put moles on bottom so that moles cancel out here. And it's moles of diphosphorus pentoxide, and I want to get to grams of diphosphorus pentoxide. And whenever I'm doing a mole to gram conversion, you remember moles is always 1. So in 1 mole, how many grams are there? Well, that's when I go to the periodic table, and I'm going to take a look at the periodic table, and I'm going to find that I have 2 phosphorus and 5 oxygen. I believe 2 phosphorus ends up being 60 something, and the oxygen ends up being 80, because remember, you have to include, there's 5 oxygen, 2 phosphorus, so you have to multiply those by the atomic weight on the periodic table, and your total ends up being, your molar mass ends up being 141.94. Okay, is your molar mass. And then you're going to go ahead and multiply that by the 0.312, and you should end up with a final answer of 44.28. And again, you want to make sure what that is. And again, if you can't see that point, let's get that a little bit clearer. 0.28, and that's grams. So make sure that you include your units there of grams. Obviously, if you just leave it as 44.28 and you don't identify what it is, then that's a problem. So it's 44.28 grams. And that would be our final answer. That's how many grams of diphosphorus pentoxide will be produced from 0.78 moles of O2. So I was able to convert from one substance into another. All right, let's take a look at what would happen if a little different perspective. What if I started in grams and I wanted to go to moles? It's the same thing, except basically I'm reversing the process. So nothing really changes. Remember, I can't go from grams of a substance straight to moles of another substance. There is not a relationship between grams of diphosphorus pentoxide and moles of oxygen. There's no relationship between the two directly. So I can't jump directly. So the only way I can get from diphosphorus pentoxide to oxygen is doing that mole to mole conversion, using my ratio from my recipe. That's the only way that I can jump from one to the other. It's just like, if I have to double a recipe, I have to take a look at my units there for how many cups of flour and how many cups of sugar. I can't take a look at the mass of sugar and compare it to the mass of flour because they're completely unrelated. And so I need to look at my moles first, which means if I'm in grams to start with, I have to get to moles first. So you can see here we have a little chart. I'm going to go from grams to moles of diphosphorus pentoxide, and then from there to moles of oxygen. So let's look how we do that and how we set that up. All right, here's our equation and our conversion. So we set up a fraction, because remember, whenever we convert, we multiply by a fraction. And I'm going to pay attention to my units. I'm in grams, so I'm going to put grams on the bottom here. Why? So grams can cancel out here. And remember, whenever I'm converting from grams to moles, it's always going to stay in the same substance. And so I'm going to put moles on top because that's what I'm trying to get into. And moles and grams, when I'm going from moles to grams or grams to moles, moles is always 1. So in 1 mole of diphosphorus pentoxide, how many grams are there? That's when you go to the periodic table, add it up, and as we already said, that answer ends up being 141. So 141.94. Okay, and again, we get that from the periodic table, adding all that up. That's the molar mass. And so then we're going to go ahead and do our math. And so we have 75 divided by 141. And we end up with a big old decimal. And this ends up equaling point, and we're going to round it off to the nearest hundredth for the moment, okay, just for sake of writing it. And remember, this is moles. And we're rounding off to the nearest hundredth. Now, I will say this. On your calculator, it will actually say like 0.52839, etc. Do not erase it. The more you round off, the further off your answer is going to be, especially if you have multiple steps. So on your calculator, go ahead and leave the full answer. Don't erase it. For sake of writing on your paper, you can put 0.53, but we do want to leave the full answer on your calculator that you will use throughout the calculations. Then I'm going to come here, and my second step, so as you look at this bottom step here, I have 0.53 moles of diphosphorus pentoxide. Now I can jump from, now that I'm in moles, I can jump from one substance to the other using my ratio. So I put moles of diphosphorus pentoxide on the bottom so they cancel out. And then I want to put moles of oxygen on top so that I can convert into that. And then I'm going to get my numbers from my coefficients. And my coefficient for oxygen is 5. My coefficient for diphosphorus pentoxide is 2. And I'm going to go ahead and put those down. Then I'm going to go ahead and do my math. And I end up with an answer that is equal to 1.32. And again, I have to remember, what is that? Those are moles, not grams. So those are moles of oxygen. And so that's my final answer. That's what I would write down on the test as my final answer as what's acceptable. So really, it's the same kind of idea that we did, except we're adding one thing. And you can tell that really, if I wanted to go another step, which will kind of be what we're going to do, the next video will be on, is if I've gotten this far, now that I am in oxygen, if I really wanted to know how many grams of oxygen is that, I could take one more step and I can convert from moles of oxygen into grams, and we would call that a gram to gram conversion, where I start in grams of a totally different substance and find out how many grams of what I need to start with in my chemical reaction. But that is for another day, and we'll stop here right now.